I found an interesting handout that I had to show you earlier with when I first introduced you the quantile regression, but I forgot to show you. So let me show you an empirical application of quantile regression, how quantile regression is applied, and how you can interpret the results. So this is from Quenker and Hallock in 2001, Journal of Economic Perspectives. So it is a survey paper about quantile regression. So it will be a nice paper to as a reference. And here they use the quantile regression to estimate the birth weight. So birth weight is an important measure, health measure for babies, newborn babies. Like so, the heavier, the healthier, right? So, and we the it is an interesting. There have been a lot of studies about what is the important factors in the birth weight model. So we like there are many variables considered: intercept, boy, married, marital status, whether the mother is married or not, black, mother's age, and mother's age squared, and high school, whether mother graduated high school, whether the mother have some college education and finished college. And here, this is a dummy variable. If the mother has no prenatal visit to a doctor's office, so it is one if the mother did not see a doctor. I don't know how it is possible. And here, second, prenatal second is just in case if you are not familiar with pregnancy, I will explain. Pregnancy is 9 month, and like medically, maybe medically, it is divided into 3 periods: the first 3 months, and the middle 3 months, and the last 3 months. Each of them is called first trimester, second trimester, and the third trimester. So this variable is whether the mother saw a doctor in the second trimester, and this is the same thing for the third trimester. And I'm really surprised. How can this be zero? How can you not see a doctor when you have a big belly? I know it's surprising. And smoker, whether the mother smokes or not, and number of cigarettes per day, how many cigarettes the mother smokes, and this is mother's weight gain and weight gain squared. So a lot of important and interesting variables are included in the model to estimate the effect of uh, effect of the variable on the birth weight. And here, as you see, the the model is estimated at a lot of different quantiles. I don't know exactly how many quantiles it is estimated, but I guess maybe say simply like at minimum say five percentile, 10 percentile, 15 percentile, 20 percentile. Like by doing this, the same model can be estimated at multiple quantiles, and all the results are collected in one graph. So this is so here maybe say this is the 5 percentile 0.05 quantile result, and on the other end is 95 percentile quantile regression. And the dotted line, the flat vertical line, is the result from the mean regression. So now let's think about the effect of what would be interesting. The effect of smoking. So first let's see the in the mean regression the effect of smoking is estimated to be somewhere minus 170. So if the mother smokes, the the baby's birth weight is on average 170 grams lower than non-smoker's baby. That is, so the average, the flat vertical line captures the mean regression result. So it captures the average effect. However, like if you look at the bottom five, like the low quantile, at the low quantile, it is going down to about minus 180. So, and the gray area is the confidence interval, but we are not going to interpret the confidence interval here. Just look at the point. So the coefficient at a low quantile, 5 percentile, for example, let me see. It does not show any. So at this the coefficient goes below minus 180. That means 5 percentile babies are small babies. They are smaller than others, right? So if you look at smaller babies, smoking has a bigger impact, a bigger negative impact. So on the average impact is about minus 170, but for smaller babies it's minus 180, and then it fluctuates around. So, but this is more flat. Overall, it moves between, say, about minus 180 and up to minus 150 something. So in this case, the fluctuation is not much, it's not big. So it's pretty much within the confidence interval of the mean regression. But now, let's think about another interesting variable. Say mother's age. So look at these two variables at the same time. Both are about mother's age. So let's ignore the square term, only look at this term. On average, additional, as the mother gets older by 1 year, the baby's birth weight increases by, say, 37 or something, 37 grams. That is, this flat line is the average. That is just average, average effect of mother's age. However, this may be misleading because the average of 37 is a combination of overall flat area lower than 37 here, and especially high impact on lower quantile. So most of the babies are affected. So the effect of age on the birth weight is around 30 something, lower than 35 for most of the quantiles. Lower on most of the quantiles on the lower side, but the effect becomes much bigger as the baby becomes smaller. So if your baby is just normal, average, and healthy baby, the mother's age does not matter. But if your baby was, say, preemie, like born small, like usually baby is born in during like after 40 weeks of pregnancy, but some babies born early, like 35 or earlier, is called premature labor. In that case, it matters. So the effect of age matters. And same thing happens in the other direction for the square term. So from these two graphs, the average estimate, the mean regression, is not wrong, but it is not exactly what we want. It means that if you look at the distribution from the quantile regression results, you can say that the most of the effect of the age, the effect of mother's age, is particularly concentrated on the lower quantiles. Lower quantiles effect is very much different from the other quantiles. that's what we find here. And similar thing can be like a lot of interpretation can be done here. Say the effect of a college degree is is decreasing. So if you are a small baby, if your baby is small, then having a college degree has a positive, like bigger positive effect. But that effect goes down as your baby becomes larger. I don't know why. I don't know how to interpret the relationship between education and birth weight. Interesting. And here is a U-shaped. It's also very interesting. Another interesting outcome is say, so this dummy variable is whether you see a doctor in the second trimester or not. If you see a doctor, of course, it will be a positive effect. However, what's interesting here is in the middle area, it's actually there is little or no effect. There is no effect. It's not significant because even if you did not, if even if the mother does not see a doctor, it does not matter because there is no problem. However, it matters if the baby is small. So smaller babies are weaker, like less healthier. So seeing a doctor will be more helpful to those babies, who are at a higher risk. So this is why there is a positive effect here, but the effect is insignificant in the middle. So this is another interesting uh, result. And as you can see, you can find a lot of interesting results here and there. So this is what I wanted to show you with earlier in the motivation, and still it's not too late. Okay, I'm going to move to the. I will continue to the identification section. Okay, see you later. Bye.